A torque converter is a type of fluid coupling used in automatic transmissions to transmit engine power to the transmission. It serves a function similar to a clutch in a manual transmission, but instead of using a direct mechanical connection, it uses fluid dynamics to transfer rotational force, torque. The torque converter also has the unique ability to multiply torque, especially at lower speeds, providing better acceleration from a standstill. Here's how a torque converter works. Basic components. Impeller, or pump, connected directly to the engine via the crankshaft. This is the input side of the torque converter. As the engine turns, it spins the impeller, which pushes transmission fluid outward due to centrifugal force. Turbine, located inside the converter and connected to the transmission input shaft. This is the output side. The flowing fluid from the impeller strikes the blades of the turbine, causing it to spin and thus transferring power to the transmission. Stator, positioned between the impeller and turbine, it has a set of blades and sits on a one-way clutch. The stator redirects the flow of transmission fluid returning from the turbine before it hits the impeller again, optimizing the fluid flow for maximum torque transfer. Transmission fluid. The fluid fills the torque converter and is the medium through which power is transferred. Operation. Engine idle, vehicle at standstill. When the engine is idling and the vehicle isn't moving, the impeller produces minimal fluid flow. Since the vehicle is stationary, the turbine isn't spinning or is spinning very slowly. The stator remains stationary due to its one-way clutch. Acceleration. As the engine speeds up, the impeller pushes more fluid onto the turbine blades. At low engine speeds, the direction and speed of the fluid coming off the turbine are such that, when it impacts the stator, it's redirected in a way that increases the torque applied to the turbine. This is the torque multiplication effect. The stator's one-way clutch allows it to stay stationary during this phase, optimizing fluid flow for torque multiplication. Speed matching. As the vehicle's speed increases, the difference in speed between the impeller and turbine decreases. The fluid coming off the turbine no longer needs redirection by the stator. The stator starts to spin in the same direction as the other components due to its one-way clutch, effectively becoming neutral in its impact on fluid flow. Lockup. Modern torque converters often have a lock-up clutch mechanism. When the vehicle reaches a certain speed, this clutch is engaged, directly connecting the engine's impeller to the turbine, bypassing the fluid coupling. This provides a direct one-to-one connection between the engine and transmission, improving fuel efficiency and reducing heat generation. Advantages. 1. Smooth power delivery, provides a smooth transition of power from the engine to the wheels, which is especially noticeable when accelerating from a stop. 2. Torque multiplication, increases torque to the transmission at low speeds, aiding in better acceleration from a standstill. 3. Protection, acts as a buffer, protecting the transmission and drivetrain from sudden shocks. In summary, a torque converter uses the principles of fluid dynamics to transfer and multiply torque from the engine to the automatic transmission. The stator, through its strategic placement and one-way clutch, optimizes this process for various driving conditions. Modern designs further enhance efficiency by incorporating a lock-up clutch for direct coupling at higher speeds.